It's the car that started life back in 2017 as the AM-RB001, the brainchild of legendary F1 designer Adrian Newey, a V12 hybrid hypercar with over 1,000 horsepower and enough aero to glue itself to the ceiling.
It's an Aston Martin Valkyrie, and yes, we have seen it before. And what we know about it already is that it is apparently the ultimate F1 car for the road. But how do we prove that? Well, look, it's Aston Martin's new Formula One car.
Well, here's Aston's new F1 car, but not its first. Back when drivers wore bow ties, Aston spent a year in F1, competing in 5 races with a best finish of 6th. This was 1959. In 2021, they'll be hoping for a lot more from drivers Seb Vettel and Lance Stroll. 3rd in the championship is the aim. The team, previously known as Racing Point and before that Force India, is owned by Lawrence Stroll, Lance's dad and a major stakeholder in the Aston road car business. So what, if anything, is the overlap between F1 car and Valkyrie? Who better to talk us through the F1 car than the CEO of Aston Martin F1, Otmar Szafnauer?
Right, Otmar, we hear a lot about the tech transfer between Formula One and road cars. We've got the Formula One car here, and I know it's 2020's Formula One car rather than 2021's. But what are the carryover bits between the Formula One car we see there and the Valkyrie we've got here?
For sure, this carbon fiber monocoque that we have here is also present here. It's a little bit bigger and the shape is a little bit different, but the technology...
But definitely F1 inspired.
F1 inspired F1 technology in the chassis or the monocoque, as well as the powertrain being bolted onto the monocoque and being a stressed member, carrying suspension loads through it. The suspension is absolutely similar to this. It's push rods and wishbones. And
all of which came from Formula One.
All of which came from racing cars and Formula One first, and now onto a road car. And I've noticed that the Valkyrie has brake ducts, which are an important and integral part of a Formula One car for many reasons, not just to cool the brakes. This Valkyrie, to me, has probably as much Formula One technology as any other road car that I know of.
And going forward in the future, do you see Formula One sort of talking, and Aston Martin in particular, talking a language between the road car and between the racing car?
Yeah, absolutely. You're absolutely right. I mean, road car designers and engineers have different parameters when they're designing, and some of those definitely apply to this. You know, we've had a brand new driver join us this year, 4-time world champion Seb Vettel, and something we never thought of in the past was the fact that when he was at Ferrari, they would have the road car ergonomics designers look at his seat position, what the steering wheel's like, the touch and feel of the wheel, how he can manipulate the different buttons, the look of it so he doesn't confuse himself from one button to the other. And now that we have a relationship with Aston Martin, the same will happen with us. We will get some of the ergonomics engineers to look at how they can help us, and vice versa. I'm sure there are technological areas where we can help Aston Martin road cars. And the beauty of the Aston Martin road cars are they're all performant cars. It's not like being at a Ford or a Chrysler where you have minivans as well as, you know, they're all performant cars. So the synergy is much, much closer.
Yeah. And just finally, it's a big car, the Formula One car. What sort of dimensions are we talking here?
5.6 meters overall length and 3.7 meters of wheelbase. Yeah, it's a big car, but you know, once again, it's all driven by performance.
In terms of performance, what does a longer wheelbase give you? Because obviously less maneuverability in tight corners, I guess, but it's just stability.
But better stability in others, better aerodynamic stability, and it's all about getting a good balance between the front and the rear of the car, and it helps in that too.
Yeah. And what's the overall weight of the car now?
So the overall weight has just gone up. With driver, it's 752 kilograms.
So it's still quite a light car, just a big car, very lightweight.
It's a big car, very lightweight when compared to road cars, absolutely. Not so light when you compare to Formula One cars in the recent past. It seems like the weight's always going up, but for understandable reasons. You know, the halos added a significant amount of weight and up high. Safety absolutely paramount in this. But yeah, for sure, there is a lot of technology transfer from racing, from Formula One, into road cars. Not all road cars, but this road car.
So that's the F1 car, considerably bigger, several hundred kilos lighter, and with half the cylinders. So not that similar. But from what Otmar says, when it comes to technology and material transfer, plus aerodynamic know-how and F1 thinking, these two are peas in a pod. Time to take that up with the chief engineer of the Valkyrie, Fraser Dunn.
So Fraser, Otmar has talked me through the Formula One car and some tech transfer and some materials transfer into the road car. But when I look across at it, what it looks like to me is that the top surface is what I understand as a more car design surface, and the bottom surface looks like that's what I understand as Formula One. Would that be roughly right?
Yeah, it's almost exactly right. So obviously the start of pretty much any car program, a road car program, is the definition of the surfaces. The lower half of the car, that was kind of Adrian Newey's domain, and that's where it was all driven by the aerodynamics of the car. And all the upper surfaces were pretty much defined by the Aston Martin design studio. There is essentially a kind of a below the line is Adrian, above the line is Aston Martin styling. Obviously there is some interaction between the two, and the upper and the lower have to work together.
Right, okay. And obviously Adrian Newey no longer involved in the car.
Correct.
But I assume the car had got to a certain level before the split out between Red Bull and Aston came about.
Yes, completely. I mean, pretty much all the surfaces that have defined the kind of the aerodynamic performance of the car are Adrian's surfaces. So it's very little has really changed since Adrian's involvement. So
okay. And what was it like the first time you had to sort of go out and get in it and drive it?
when you first get in one of these, it actually is quite a kind of a terrifying situation to find yourself, because you think it's going to be a scary car to drive. But literally, as soon as you start kind of getting used to it, it's actually a very intuitive and very easy car to drive.
And what about when you start going a bit quicker in it?
It stays the same. I mean, ultimately, we're slowly turning on all the active systems on the car, which it heavily relies on to give it its level of stability that it will eventually have when it's fully tuned. But even as a fully passive car, so none of the active working, the car is still very easy to drive. So,
right, I'll take your word for it for the time being. So it just looks borderline terrifying to me. Right, let's go and have a look at the detail of it.
We'll start at the obvious place, the front.
It looks to me like you've got an enormous amount of air capacity going straight in the front, but that top layer looks like a really thin layer.
if you actually compared the two cars, if you were to take all the kind of the green coloured panels off that you see here, you have the same nose box that you'd have on a Formula One car, and you've got the kind of the wing hung off the underside of the nose box. So the whole kind of premise of the car is Formula One aerodynamics. So you need the wheel arches and you need somewhere to hang your headlights and everything, and that kind of defines it as a road car. But ultimately a load of the features, so these cutouts here by where all the wishbones are and everything, that is all a part of the aero strategy of pressure relief and getting air back up on top. And this whole area here is about energising the back end of the car. And
charging off towards the rear wing.
And then obviously mediated between Adrian and Aston Martin's styling department so that they were happy. Yeah. He was happy with the aero. Bit of conflict.
Was that more of a battle? Was that a conflict, or was that quite?
And I think both sides would probably always see it as a kind of a positive thing, because you kind of need that kind of to and fro to end up with something that works.
Yeah, so. And your job in that is sort of
mediating. To a point. Yeah, definitely.
Excellent. And just looking up the bonnet, can you run with a vertical windscreen wiper like that?
Yes, totally. So we've that is the nominal position in the vehicle settings. You can actually set it to one side or the other, but in the kind of the purest form, obviously it looks a bit like an LMP car, but also from the point of view of aerodynamics, if you have it dressed one side or the other, it will actually affect the airflow around the car. Not to a point that you'd actually have any issues, but it's just not the right way to be if you've got a car that's designed around an aerodynamic ideal.
Did you have to make that a bespoke part, or have you managed to get that off the shelf from somewhere?
Oh no, that wiper is completely bespoke. We actually used a supplier who, their other other customer is NASA. So it's the first time we got into kind of talking about volumes, and they said, oh right, okay, well 150 is bigger than what we normally make. We're normally in the kind of the realms of 10 parts. So
really, so windscreen wipers for space shuttles or something?
Well, no, they do all sorts of other stuff, but it's kind of aerospace. So
wow, if we look at the front wheel, for instance. You've got the brake caliper, but you've also got what looks like a carbon frame running in there as well. What's that about? Even
on normal supercars, you have kind of a relatively kind of passive air cooling. So you'll probably have upsweeps or vanes that will throw the air in the general direction of the stuff that gets hot, i.e. both the disc and the caliper. On this car, if you were to look fully inside the wheel, you've actually got a duct on the inside disc of the wheel, like a Formula One car, which then forces air, and then that, instead of it just blowing into the wheel, every single piece of air has its own vane within that duct, which is either going directly to the center of the disc, going to the caliper, and it cools all the bits at source, so it's as efficient as possible. But then on top of that, all the air, instead of them blowing out the front of the wheel, it's all scavenged out the inside of the wheel, which means that the air going down the car is cleaner, because you don't end up with a big wake coming out the front wheel.
And carbon brakes, are they?
It's called CCMR. It's a constant strand ceramic composite disc. It's the kind of the latest and greatest. It gives you relatively good cold performance. It also gives you the refinement that you need in a road car, but at the same time gives you the high performance.
Yeah. And what temperature do they like running at?
Well, that's the beauty of these. These will be fine at kind of at room temperature. They will give you that initial bite. Where they actually start really working is 600 up. So.
And what sort of braking force can you generate?
So at the moment we're still in the kind of development phase on working up to kind of ultimate performance, and we haven't actually fully started resting on the brakes, to be fair, and actually getting those numbers, because we're looking more at the dynamic stuff at the moment. From simulation, the aero that the car makes, and therefore how hard we're pushing it into the ground and what the brakes are capable of, it should be braking at around 4G.
4G?
Yeah.
Wow, and you can pull, what, 3 through corners? Is that?
No, it's over 2.
Over 2, okay.
Yeah.
Huge G-forces, sophisticated brake ducts, a teardrop-shaped passenger compartment, and aerodynamics that guide every molecule of air along specific channels to enhance performance. Okay, this is starting to sound quite a lot like an F1 car.
Right, let's have a little look further down the car, and the first thing I've noticed is obviously you've got cameras, mirrors on the side. Are they exactly as they're going to be?
Yep.
And are they going to move in and out, or they just
sit
there?
That is them in their fixed position. So it's kind of the latest technology of kind of camera systems. So it's actually got a kind of a mechanical iris. Part of the reason that they've ended up on the car is due to, again, pushing for the maximum of kind of aero performance on the car. So the benefit it gives you is that you don't end up with a load of turbulent flow down the side of the car, and you've got it as small as possible. The problem you've got with a road car over a Formula One car is that within road cars you have a minimum mirror head size. We can replicate that inside the cabin. But if you put that on the outside of the car, it would have ruined Adrian's aero.
So, and then a much bigger bit of aero just below it, you've got the barge board here. I'm going to refer to it as a barge board because that's what I know them as on Formula One cars. Do you call them the same thing?
Well, only because they're only ever normally seen on Formula One cars, and they're called barge boards. So yeah, we ended up calling it the same thing.
Yeah. How does the air work in that area?
Well, essentially, it's if you imagine we're trying to create a tunnel that then comes round and then feeds round the back of here, and it also sets off with these vortex generators here on the floor.
And the vortex generators, I'm right in thinking, turn the air inwards back inside
Correct.
the rear wheel.
Yep.
So they're designed to sort of create a pressure wave pushing the air back in, which is exactly the same as on the Formula One car, isn't it?
So the whole kind of purpose of all the details on the floor is to make the diffuser work as powerfully as possible.
Diffuser.
Yeah.
How much downforce is the diffuser generating for you?
Well, it's not just, I mean, obviously the diffuser is part of the package. So you need the whole car. So for example, the diffuser wouldn't be as powerful as it is if it wasn't for the design of the front wing. But the whole car makes its own weight in downforce, basically.
Which is shocking.
Yes. Most cars, as soon as they start moving, start getting lighter due to lift.
Yeah.
Whereas this thing, when it's making peak downforce, it's making its own weight again.
Really?
So,
How much does it weigh?
We'll move on from that one for now. Get the whole way up the diffuser. Gonna have a snooze in this.
You're right.
Oh, grand.
So if we come back and look at the rear diffuser, it's twice the size on here than it is on the Formula One car. Is that just because you can?
yeah, exactly that. So ultimately the restrictions that the FIA put on Formula One mean that they end up with a much smaller diffuser than they could if they were allowed. So
Yeah.
if they had their own way, they would all look like a Valkyrie, essentially, which is a bit mental.
Yeah. But I guess as the car is here, you're generating a lot more downforce from your diffuser than you are from your wing.
Correct, yes.
Yeah.
That is the most powerful thing on the car. Obviously, if you look at the size of the wing on the Formula One car, it's much bigger, and that would be obviously way more powerful than this. But the wing and the diffuser actually work together as well. That's another part of the whole thing, because obviously that generates more pull on the underside of the car. So that's another mechanism by which they make their smaller diffuser more powerful.
Right, I see. And then I look at some of the details on this, because obviously where you've got this, I believe it's the rear crash structure, is it?
Yes.
So it looks exactly the same as you've got on the Formula One car.
Exactly.
You've just got a carbon beam out the back of it. By the
Yeah,
looks of
I
it.
mean, obviously there was a lot of Formula One kind of engineering involvement on the program that this kind of arrived in the design, and obviously you can't end up with a big long bumper beam like you would on a normal car because of everything that we're trying to achieve. So we ended up with that, and then we started kind of going through all the simulations and.
And you can get it through crash regulations.
Yep.
And then you've got the exhaust exiting on top of it, which again is a Formula One thing. You didn't think about putting the exhaust in and having like a blown diffuser or something.
It was discussed. It was discussed early on. The only problem that we have is exactly the same issue that they had in Formula One with blown diffusers, which was literally after a 2-hour race, you've got to throw it in the bin because you've burnt all the carbon. So, it's not a viable kind of proposition for a road car.
But I assume you've got an enormous amount of heat being generated because you've got this panel on the back there, which is not the prettiest panel at the moment. I know it's not complete on this
it's
car.
a prototype version.
Yeah,
And it will
but you've
look
got a lot of
nicer.
heat. So what have you had to do to like the rear wing and that area in order to allow it to cope with the heat?
So it comes down to materials. So I've heard, obviously, Otmar was explaining the transfer of material technologies and what have you. The interesting thing is that a lot of the material technology is actually the grandfather of a lot of this technology is actually aerospace. Some of the materials that we have in areas of the rear wing is essentially the same stuff that they use in high temperature areas of fighter jets, Formula One cars, nozzles of missiles. So
Wow.
it's kind of cutting edge material.
It's been 26 years since a V12 competed in Formula One, so the engine link is tenuous at best. But just look at what we have here. A compact, lightweight, 6.5 litre naturally aspirated V12 designed by Cosworth, developing 1,000 horsepower and revving to over 11,000. And it sounds, well, get a load of this.
What strikes me when I first look into it is the tightness of the packaging in there is astonishing. What have you got going on where? What's going on up here?
So that's what we call the Bootstrap Reservoir. So that's part of the hydraulic system. So
One hydraulic system runs all of all the systems on the car.
yes,
as it were.
exactly. And that's
Right.
so it's active aero, the active suspension, and also the gearbox controls. So when it changes gear, it uses that system with both the shift and also the clutch actuation.
And where does the air come? So the air comes in down here.
For the
engine?
for the cooling.
For the cooling, yeah.
Cooling comes in on those intakes on the side there, and then the radiators sit here on both sides of the car,
Yeah.
and then that literally blows through a void which is closed by this panel and the underside of the floor,
Yeah.
and then literally all the cooling air comes out of these two holes either side.
Engine air comes in on top up here
Yep, exactly like you would have on a Formula One car.
and down through.
Yes, so this is essentially your air filter. It doesn't look like a normal air filter,
No.
but this is complete, again, it's kind of pushing the boundaries on things, but when you're driving the car in the rain, you'll
Yeah.
end up with a load of water coming down there and is going to end up on your filter. So this is actually a hydrophobic film that is also a filter, so any water lands on here and then drains down that hole there. Yeah.
So that is literally, that little membrane is all the air filter you've got for the engine.
Correct.
Ooh, that's quite trick, isn't it? And the water all runs off in there, the air goes into the engine, goes bang, generates a lot of power.
Simple.
And where does your hybrid system sit? Does it sit between engine and gearbox?
The battery lives pretty much just behind the seats, and lives with the fuel tank. The motor sits in between the engine and the gearbox.
It's not a hybrid system like the Formula One cars is a hybrid system.
The way that we're actually deploying power is very much similar to what they use on a Formula One car.
So how are you using the power on this?
So obviously the car has no reverse gear. That is provided by the e-motor. Pull away, or kind of just the initial pull away to give you the hygiene factor is by the e-motor. But we also use the e-motor for the actual gear shift. But the thing that's similar is that the car essentially has an ERS button in the car. So when you want another 150 horsepower above the 1000 that you've already got, you just hit the button, you're off.
Right then, the final area we need to take a look at is the cabin.
One leg, two leg. It's a long way down, but my feet aren't going down. My feet are staying really high. Let's just pull that down, get the full experience. That's all right. Right, steering wheel. Gotten caught on cables. This is quite interesting and very cool. You can hold the steering wheel at any angle. You can put it on like that, and then you turn it to there, and it's locked on properly, really nice and simple. It feels like being in an LMP car. It doesn't feel like a road car at all. Your feet are really high and you've just got your backside really low. And then you're looking out and I've got this really long windscreen that sort of tucks away from me. Very high wheel arches either side, so it feels really restrictive. You've got the screens here for the mirrors, and this screen, which is actually going to be up on the roof for the production cars. And I should explain actually that the reason that there's a lot of cables and kill switches and all the rest of it in here is that this is a development car. It's the one that's done a load of miles, so it looks very pretty outside. In here, it's full of data loggers. Steering wheel is mostly intuitive actually. You've got all sort of regular buttons for nose lift and launch control and so on.
To switch on the ignition, you push this button here. The lights come on, the screen lights up, and the most important bit, the rev counter doesn't redline till 11,000.
These paddles, which have a fantastic action, do actually come from an F1 car. They won't tell me which one, however. But the overall experience of being in here is you're just aware of the whole thing feeling like you're in the nose cone of something. You know, the way these sides come in. So when you've got a passenger in here and you're both crammed in and you've got no sort of binnacle area between you, it's going to be really tight. It feels fantastic and different, but can't really see much places to store wallets and phones and keys at the moment. Right, Fraser's gone. Otmar's gone as well. There's a Formula One car over there. I think I'm going to go and see if I can have a sit in that. F1, baby. Oh, better take the steering wheel off. Hope it works like a normal one. Let's put that up there very carefully. Right. What do we think? That looks all right. Oh, I'm not sure I'm going to fit through this. Yikes. Oh. Oh, once you're in, you're in. Right, let's get the steering wheel on. Feed it through the halo. I hope it works just like a normal one. Let's see if it just pushes on. Not easy to line up. There we go. Wow. I mean, sitting in an F1 car. It's really cool. I mean, the halo doesn't really get in the way too much. I'm amazed by what if this little piece of perspex is. It's all jagged. Must be something to do with breaking up the airflow. And then the steering wheel. You just don't know where to begin with the steering wheel. But the driving position, it's quite a lot like the Valkyrie. I mean, I think I've got more elbow room in here than I had in that. I mean, what it must feel like trying to go fast in, I have no idea, and I will never have any idea because I'll never drive one of these. That, though, I know it's been delayed. I know it's been delayed for quite a long time, but we'll be driving it this August, and that is something to be really excited about.